Understanding scikit-learn's partial dependence plots (PDP). Partial dependence plots (PDPs) are a powerful tool for understanding the relationship between a target variable and one or more features in a machine learning model. They help visualize the marginal effect of a feature on the predicted outcome, holding all other features constant. This is crucial for understanding the model's behavior and identifying potential biases or nonlinear relationships. Here's a breakdown of scikit-learn's implementation of PDPs. 1. Key functionality. sklearn. Inspection. Partial dependence. This function computes the partial dependence of a target variable on a set of features. sklearn. Inspection. Plot partial dependence. This function visualizes the computed partial dependence values, providing insights into the feature-target relationship. 2. Input parameters. Estimator. The trained machine learning model for which you want to analyze the partial dependence. X. The dataset used to train the model. Features. A list of features for which you want to compute partial dependence. This can be: an integer represents the index of a single feature. A list of integers represents multiple features. A string represents a feature name. A list of strings represents multiple feature names. Kind. The type of plot to generate. Options include: average. Default computes the average partial dependence over all data points. Individual calculates the individual partial dependence for each data point, showing variation in the feature effect. Grid resolution. Number of points in the grid used for calculating the partial dependence. Higher resolution can lead to smoother plots but also increase computation time. Method. The method used to calculate the partial dependence. Brute. Default computes the partial dependence by iterating over all data points and changing the value of the target feature. Recursion computes the partial dependence recursively, which can be faster for models with complex interactions. N jobs. Number of jobs to run in parallel for computation. 3. Output. sklearn. Inspection. Partial dependence returns a tuple. Average predictions. NumPy array of average predicted values across all data points for each feature grid point. Individual predictions. NumPy array of individual predictions for each data point and each feature grid point. Grid values. NumPy array of grid points for the specified features. sklearn. Inspection. Plot partial dependence generates a matplotlib figure visualizing the partial dependence relationships for the specified features. 4. Practical applications. Feature importance. PDPs can help identify the most influential features for model predictions. Model explainability. They provide insights into how the model behaves in response to changes in specific features. Feature interactions. PDPs can reveal interactions between features, indicating whether the effect of one feature depends on the value of another. Model debugging. Identifying potential biases or unexpected relationships in the model's predictions. 5. Key values in the YAML example. YAML. Model type random forest classifier. Features age, income, grid resolution 50, kind average, n jobs -1. Method recursion. Explanation. Model type specifies the type of model used. Here, it's a random forest classifier. Features. The features for which we want to compute and visualize the partial dependence. In this example, age and income. Grid resolution. The resolution of the grid used for calculating the partial dependence. A value of 50 means that the partial dependence will be computed at 50 points along the range of each feature. Kind specifies the type of plot. Average means we want to see the average partial dependence across all data points. N jobs sets the number of CPU cores to use for parallel processing. -1 indicates to use all available cores. Method: the method used for computing partial dependence. Recursion could potentially be faster for models with complex interactions. 6. Considerations. Data scaled for models that require scaled features. Make sure to scale the data before using partial dependence. Computational cost: PDPs can be computationally expensive, especially with large datasets or high grid resolution. Interpretability: PDPs are powerful but may not fully capture the complexity of high-dimensional interactions between features. 7. Conclusion. Partial dependence plots are a valuable tool for understanding and interpreting machine learning models. By visualizing the marginal effects of features, they provide insights into the model's behavior, highlight influential variables, and aid in identifying potential model issues.